So a quick review, a Bronsted-Lowry acid donates an H+. Bronsted-Lowry base accepts an H+. Now I'm going to introduce you to conjugate acid base pairs. So these are species that differ only by an H+ in their chemical formula. When an acid is ionized and H+ is removed, what's left is called the conjugate base. The stronger the acid, the weaker its conjugate base. The weaker the acid, the stronger the conjugate base. So HCl is an acid, and Cl- will be its conjugate base because it can accept an H+ to become the acid. So HCl and Cl- are conjugate acid base pairs. HCl is a very strong acid. That makes its conjugate base very weak. Acetic acid differs from its conjugate base by an H+ in its formula. So the acetate ion is the conjugate base of acetic acid. They differ in formula by an H+ in their formula. The acetic acid is a weak acid, so the acetate is a stronger conjugate base. When a base accepts an H+, the new particle becomes a conjugate acid. So if an acid is ionized, it leaves behind a conjugate base. When a base accepts an H+, the new particle becomes a conjugate acid. The weaker the base, the stronger the conjugate acid, and vice versa. So if we're looking at ammonia, and it will accept an H+ from water, it will form the ammonium ion. So the NH3 and the NH4+ are the conjugate acid base partners. So ammonia is the base. So ammonium is the conjugate acid. So if you're an acid, you have a conjugate base, and if you're a base, you have a conjugate acid. So let's consider the following. We've got acetic acid plus water, and then on the right-hand side, we've got the hydronium ion, H3O+, and the acetate ion. So which partners here differ in formula by only an H+? So we're going to look at these and we're going to join them with a line. So this and this differ in formula by an H+, but so do these. So you'll have, if you have a reaction, you have two conjugate acid base partners. So this is our acid, which makes this our conjugate base. And if this species here acted as an acid, that means this one must have been its base. And it was because it accepted an H+. So water is acting as a base. That means the hydronium ion is its conjugate acid. So on the left-hand side, we will have an acid and a base. and their partners on the other side will be conjugate partners. So if we look now at the next part, example 2, we have ammonia, we have water, we have ammonium and hydroxide. So if we look at these two, these differ in formula by an H plus, and so do these two. So in this process, ammonia went to ammonium. It gained an H plus, so that makes ammonia a base. Water went to hydroxide, so it lost an H plus, so it was the acid. That means the ammonium ion is the conjugate acid, and the hydroxide then is the conjugate base. Buffers. Buffers are really important when working with enzymes, and we have buffers in our blood. Basically, a buffer contains both an acid or a base and its conjugate partner. And what happens is you can add either H plus or OH minus to this, and the mixture will buffer the pH. It will use up the H plus or the OH minus to keep the pH constant. Identify the conjugate acid. So we want to find an acid of this substance. An acid would have had an extra H plus to give. So this had to have an H plus in it. So to do that, you add an H plus to the formula that you have. So I will now have two H's. And the charge, 1 plus and 2 minus, becomes 1 minus. If I want to find the conjugate base of something, I have to remove an H plus, because that means this is acting as an acid. So now I'm looking for this species minus an H plus. So CHO2 negative. I only lost one H plus. So remember, when you're looking at equations or chemical reactions, identify your acid and your base, and their conjugate partner will differ from them by only an H plus in the formula, so they're easy to find. And if you were an acid, you produce your conjugate base. If you were a base, you produce your conjugate acid. And you can always figure out the conjugate acid that a base came from, and you can also determine the conjugate base of an acid based on formulas. You're just adding or subtracting an H plus from the formula.